Hi, my name is Hasyim bin Rafee. Card matrix number is B082211100205. Hi, greetings to Dr. Radi Hussein, and this is our teammates, GHUGAAN anak lelaki Kanigasalan, Nathan, Randall anak James Beei, and THUSYEANTHAN anak lelaki Kumar. So I'm taking this slide to present about how the process from the transfer function is converted to the dot plot. So for the transfer function, we need to know that the magnitude of the plot is in decibels, that is dB, a phase angle versus frequency plot for a transfer functions. So here, the magnitude of the plot, which is the dB, can be converted to the logarithm scales, and the frequency is a logarithm scales too. The slope is represented as a dB or decade. The dot plots replace curves by straight line approximations. Dot plots represent the 7 factors separately and the edges then graphically. The 7 factors is contains constant gain, pole at the origin, 0 at the origin, simple pole, simple 0, quadratic pole and quadratic 0. So here we need to convert our equation, that is transfer function, to the standard form, that is h omega equals to k j omega 1 plus j omega over z1, 1 plus 1 plus j2 omega over omega k, and plus with j omega divided by omega k power of 2, and the whole numerator equals will divided to j omega 1 plus j omega over divided by p1, 1 plus j2 omega divided with omega n plus with j omega divided with omega n power of 2. So to convert the standard form of the transfer functions, we use these equations that I said uh, just now. So here we got the equations. H omega is for the transfer function is 50 j omega divided with j omega plus 4 and j omega plus 10 power of 2. So this equation will be converted to the standard form. So how is it? So we need to separate the power of 2 into two equation that is partial fractions. So that will be j omega plus 4 and j omega plus 10 followed by j omega plus 10 too. So to convert in the standard form will be the 1 plus j omega divided by p1. So I divided each of j omega plus 4 with uh, the ons their numbers, like this. J omega plus 4 divided by 4, j omega plus 10 divided by 10, j omega plus 10 divided by 10. Because of the power of 2, we need to separately change like this. So if we divided the denominator with 4, 10, 10, the numerator also must be divided with 4 and 10. That's the rules. So the constant gain we will get like this. So for the new equations, the equation will be like this: 50 j omega divided by 4, 1 plus j omega divided by 4, 10, 1 plus j omega divided by 10, 10, 1 plus j omega divided by 10. So the numbers that outside of bracket will be multiply, and it will be 400. The value will be 400. So the new equation will be 50 j omega divided by 400, and in the bracket will be same of the previous equations. So it will be the 1 plus j omega divided by 10. That equation will be the uh, originality from the equation again, that is power of 2. So 50 j omega divided by 400, 1 plus j omega divided by 4, and 1 plus j omega over 10, that power of 2 based on the equation given. So we from this we got the zeros and poles, which is the 50 over 400 j omega is the zeros, the 1 plus j omega over 4 and 1 plus j omega divided by 10 is the poles. So the poles is equals to 0, all the equation the both bracket. So the j omega plus 4 equals to 0, then the 4 is will be at the right, that j omega equals to -4. The positive 4 will be -4, and j omega plus 10 power of 2 equals to 0. The 0 will be square root, and 0 square root will be maintain 0, and j omega plus 10, the plus 10 is moved to right hand side. The j omega will be -10. So the new zeros will be 50 over 500, and the poles will be -4 and -10, based on the equation that we equals to 0. So this is our new equation that have been converted from the transfer function to standard form and constant gain. So now we need to find the decimal, that is HDB. So here the poles will be the negative log, and the zeros will be positive log. So here we have 50 over 400. So the 50 over 400 will be positive 20 log, and the j omega in the zeros will be positive 20 log. At the poles, 1 plus j omega over 4 will be negative 20 log, and 1 plus j omega over 10 will be negative 2, negative 20 log 2. So here we multiply the 2 multiply with 20 is because the power of 2 will be in front of the 20 log. So we multiply the 2 and 20 will be get 40 log. That's why here are the 40 log will be represent. So here we know that 50 over 400 is 1 over 8. So we need to change it with the whole number. So the positive 20 log will be negative 20 log, and in the bracket we change the positions, that 50 over 400 change with 400 over 50, that we get 8, that a whole number. So the new equation will be negative 20 log 8 plus 20 log j omega negative 20 log 1 plus j omega divided by 4, and negative 40, that is we multiply 2 multiply with 20 log 1 plus j omega over 10. So we inverse the 400 over 50 to get the whole number. So for the phase, we got at the 0. So for the phase, we got the 0 degree is from the constant of 50 divided by 400, and 90 degree from the 20 log j omega. We can see from the transfer function 2 that j omega will represent at the zeros position, and the negative tangent inverse that we take from the 20 log j omega over 4, and negative 2 tangent inverse omega over 10 we take from the negative 40 log. So the negative 2 is because of the negative 40, that negative 40 we get from the 2 multiply with 20.
Okay, hello. My name is Natarina, anak James BAE'E, matric card number B0822101171, and I will be explaining about the how to transfer the transfer function to board plot magnitude. Okay, this is the value, the equation that we have, and the first value is negative 20 log 10 8. As we can see, there has no j omega, therefore it is a straight line. So here it is, from here, negative 20 log 10 8. After that, we see this, and as we can see, there has a j omega, therefore it is divided by 1, and it will have a cut off here at cut off 1. And as you can see, it is positive, therefore it goes upward and cut off 1. After that, we see the third value, and it is the cutoff is 4. So it is starting 4 will be cutting off, and it is a negative, therefore it go down. Okay, go down and cut off for one space to negative 20 log. And lastly, we have 10 cut off, so it is here, and then it is negative, therefore it cut down until to 40 here, negative 40 log 10. After that, we must do the total one, and therefore we must see, okay, upward and straight line, therefore it is a positive until the uh, cutoff 4 is stop there. And then we see here is upward, and then this is downward, therefore it is a straight line until the another cutoff for another 10. After it reaching 10, both of the value is going down, therefore it is go down until here. Okay, that is all. Thank you.
Hi, my name is Dushyant son of Kumar, and my number is 10 B0822101009. And based from this equation, so now we plot the pasteboard plot and plot in the semi-log graph. From this equation, we plot the graph. From the equation, we plot the graph like this, and the equation show that the negative 0 degree is the from this graph is the line is become down, and this is the line for 90 degree, and the negative tangent shift omega over 4 is line from the negative 90 degree from this line. This is the negative tangent shift omega over 4, and also this is the last of equation is negative 2 tangent shift omega over 10, and this is the angle of 90. This is 90 degree, and this is the line from 45 degree from this side, and this is the for line for negative 45 degree deca. For we draw the line from dot line from the 0 to downside, and the negative 135 negative 135 degree of deca is we get from negative 45 deca plus negative 45, then we get the negative 35 or degree of deca. After we draw all the dot line from this equation, we can draw a straight line from 90 degree to the downside from that is negative 35 degree of deca. That's all. Thank you. And lastly, we can say that this is line for the negative 90 degree, and this is a line for the 0 degree, and this is a line for the negative tangent shift omega over 4. That's all. Thank you.
Hello and good morning to Dr. Radi Hussein. So my name is Bugan Anariki Kanigasalan and I'm from class 2 BET S2/2. So today me and my team going to explain about the assignment that given for the subject advanced electric circuit. So my part is part B which consists of bot plot graph changing into a transfer function. So this is the graph. So as you can see, this graph is uh, HDB against omega radian per second. So at the 40 mark, we can see a constant straight line, and after that, two stages of changing is happening, which are at the mark of 100 radian per second and also 1000 radian per second. As you can see, this slope is negative 20 dB per deca. So from this information, we can get that equation, which is 1 plus omega per 100 and also 1 plus omega per 1000. As you can see, the corner frequency for this from this graph is 100 and 1000 radian per second. So at this part, I have simplified the standard transfer function of formula, which consists of uh, j omega plus zeros and j omega plus poles, and also consists a value of k, which I simplify to find the value of k later next on the calculation part. So the formula for the simplified transfer function is k 1 plus j omega over zeros and over 1 plus j omega over poles. So continuing to the next part. So as you can see the slope, there's an increase by plus 20 dB per deca and also a decrease by negative 20 dB per deca. So as you can see, the positive 20 dB per deca consists of zeros, and also the negative 20 dB per deca consists of poles, which these two zeros and poles are being presented in the graph. So as you can see, for the 100, the slope is 20 dB per deca is changing to negative 20 dB per deca, and the slope is added. So this can bring us a phenomenon called simple pole axis. As you can see, the 1 plus j omega over 100 is the denominator, and for the second part, which w equals to 1000, the slope is at 0 dB per deca is changing and the slope is added. So this also causes the phenomenon called simple pole axis. So with these two hundred and thousands, we can create the equation and also will calculate the using the formula. So for the final part, as you can see, so from the formula that the simplified from the transfer function, as you can see, we have k j omega over 1 plus j omega over 100 times it with 1 plus j omega over 1000. And as you can see, I have factored out 1 over 100,000 from this section and also multiply it and bring it above to the k omega. So it becomes 100,000 k omega over 100 plus omega 1000 plus omega equals to uh, equals to 100,000 times 0.1 omega over 100 plus omega times it with 1000 plus omega. So as you can see, this 0.1 value is the k. So how do I get it? I get it using 40 log 10 k equals to negative 40. So as you bring the 40 log 10 here, the k becomes 0.1. And you've been wondering why there's negative 40, because as I show them above, plus 20 and also a 20 dB per deca is present. So as you can see, the total values adds up to negative 40. So the 40 log, which is the constant straight line, and also the equal final answer, which is negative 40. This brings us with the k with a value of 0.1. So at the end, it will be 10,000 j omega over 100 plus omega, multiply it with 1000 plus omega. So that's all from me. Thank you very much.
As a part of discussion from the transfer function equation, we convert to the standard form and plot the graph, which is magnitude plot and the phase plot. The magnitude plot represents the system gain or attenuation of the signal with the different frequency. From the bot plot we have obtained the transfer function of the linear invariant system. We also obtain the transfer function from the magnitude, and we take the value and plot it against the frequency on a semi-log scale.
For conclusion, in this study, we have learned to convert the transfer function to standard form and obtain the magnitude and phase angle from the equation. Other than that, we also convert from transfer function to dot plot logarithm for part B that consists magnitude and phase too. That's all. Thank you.